Hello, allow me to start a kitty program intermediate whereby there's an assignment that I'm required to train a machine learning model to help in classification of load application as approved or rejected. So I'd used Jupyter library to come up with this particular program. Then after coming with it, I've just opened it now using the VS Code. So to begin with, we're going to import libraries that are going to help us in execution of this particular program. And the first library is to import numpy as np. And the function of this is to manipulate data from an array, and also it can also perform arithmetic problems. The next library is the import pandas as pd. So this one manipulates data frames in table form. Then we have matplotlib dot pyplot as plt. Generally, the main function for this is to plot graphs, badge, scatter plots, etc. Then we have import seaborn. Generally, seaborn help us to improve the plots to come up with a more regular or a much understandable curves or graphs or bar charts. Then after that, we're gonna have what we call the sklearn model selection. So generally, under this, we're gonna have several of them. To begin with, we're having the train test split. Here, it's to split data into training and also another data into for testing. So generally, that one helps us to split data into training and data sets. Then we have sklearn preprocessing. So generally, this one now helps us in will help us to manipulate the scalar form and also the encoder, especially now when you're dealing with the numerical and categorical factors. Then now we move now to the column transfer. Generally, that one will help us to understand. Column transformer. Generally, that one will help us to transform our columns into our desired applications. Then we have logistic regression, which is now the actual parameter that we need to use in this particular program. Then you have pipeline. Generally, pipeline just will give you a guidance or a flow of execution of a program. Then we shall import sklearn matrix. In this particular case, we shall be able to come up with the confusion matrix, the rock curve, the classification report, etc. So after having those libraries with us, then now you move on. We go. Then the first step is to load datasheet. It means the data that was provided by the kitty that we're supposed to use for training. I import it, and now I'll use the df head. This one now will confirm and will display the table as below. So the df head now confirms that the data set is is downloaded and uploaded to this particular program, and it is given into about 5 rows. Yeah, and you can see we have age, monthly income, employment type, loan amount, loan purpose, credit history, repayment defaults, membership years, guarantors, loan status. So after that, we move now to exploratory data analysis. So we want to analyze our data that is given above, and in this, we're gonna look at just a minute. in this exploratory data analysis here, we're going to look at now, we want to print the loan. I mean, we should be able to print the loan status and also have the loan status distribution. So generally, it's we're going to have or print categorical features and numerical features. So when you look at the column here, the categorical features, generally we have the categorical features that we have here. We have employment type, whereby we have self-employed and so on. Then we have another categorical type, which is loan purpose and credit history. But then numerical, we have the monthly income, we have the loan status, the repayment defaults. So generally, the numerical features are those that have numbers. Categorical are those that do not have numbers and have more than two features. So after that, you'll come up with the loan status distribution, and whereby you have the count and loan status and at the x-axis and the count at the y-axis. So after having that categorical and the numerical features, then now we convert the categorical, that is guarantors column, to numerical. So if you look at, so we're gonna convert or get dummies. That is when you look at our first table here, under guarantors, it was either yes or no. It was yes or no. So wherever we have, so we'll just be able to convert this to dummies, whereby the no we shall use 0, and yes we shall use 1. And now that is what these dummies has helped us. And if you look at these guarantors now, the 0 represents a no, and 1 shall represent a yes. Then after that, you go to now the employment type, whereby the array that we had self-employed, informal, unemployed, and formal. In this particular case, you realize this is a categorical data having more than two variables, and in this particular case, it means we cannot really have, or we cannot change them to dummies. The same happens to the loan purpose, whereby we have farming, housing, business expansion, and fees. That is why we are going to use the DF for employment type and loan purpose, because these are categorical data having more than two variables. And also the credit history here. The credit history here also shall consider having poor, good, fair, and so we have all those three. We have those three variables that are categorical, and they'll have to appear as they are. So if you look at the DF head and you run the program, you'll now see under employment type, you have self-employed, informal, formal, also loan purpose. Also, you realize that it's categorical and we cannot convert it. Also, credit history, that one also cannot be converted to numerical. That is why. So then you go to the fill, in place 0, in place true. So you realize that now none, there are those components under membership years, wherever you have none, the fill none now will convert these nuns to be 0, because you realize that it is fill none in place of true, meaning wherever you have none here, you replace it with 0. So for example, if you look at this previous table, we had the membership years, whereby we had none here, another none, the three following one another. But now, after now DF fill none, we're gonna change the nuns to 0. And also we have another none under loan amount, whereby now it will be converted to 0. It means here it's in a language that can be understood by it can be easily understood by the system. So after having that, we're gonna come to call to scale and call to encode. So call to scale here, we're gonna use the numerical features, and call to encode will only consider the uh, what we call the categorical features. So under that, you realize that numerical here represent the numerical, and that is why we're gonna use call to scale for numerical, and call to encode for categorical. So that one now again, all the numerical data, and you call to scale generally makes it or generally ensure that the data has a range that can be managed by the system. And that is why now if you look at the monthly income, the average is being displayed there, or rather the range, which can be really understood easily by the system. So then when you come to x is equals to df, y df, generally here we want to now develop a presentation whereby in x-axis we'll have the loan status, and you all drop all the columns excluding loan status. In x-axis you'll have all the columns including monthly income, employment type, loan amount, etc. But on the y-axis you will only have the loan status alone. So x-axis you'll have all other columns or parameters except the loan status, but in the y-axis you'll only have the loan status. And also now the next program now will be now training and train, test, split. Here we have to train our program, and in this particular case the test size will be 20%, having a random state of 42. So after that now you'll be able to do the logistic regression model training. So this one will be the actual training, whereby when you put the preprocessor and the logistic regression now, and you run the program, it will give you the pipeline. I said the pipeline generally is the steps that the program shall follow to execute a given problem. So here you have the pipeline in bracket steps, whereby whereby you'll have the numerical and categorical. So under categorical, you drop first there, then numerical, then the logistic regression. So generally, the pipeline will help us to give us the steps that this particular program shall follow. Then you go to now the model evaluation, whereby there is that accuracy of 0.5, and the classification report will be provided in that particular manner. Then the confusion matrix will also be developed using this particular program, whereby you have confusion matrix in brackets y test and y predict, whereby we have uh, uh, it will be able to know the false positive rate, true positive rate, and also the predicted actual information that are provided by the particular data. So this one now help us to come up with a confusion matrix, and also from there also we shall be able to now develop a rock curve, and from the rock curve now you can see, and whereby it's a plot between a false positive rate or rather against a true positive rate, so that you'll be able to come up with a rock curve having a kind of a rock score of 0.5, 0.53. So generally this one is one this one is a project or a, a machine learning model that is being used to train loan application, so that it can either be approved or rejected depending on the pipeline or the analysis that has been done to the uh, data that you have provided. Thank you.